5.1 Data Concepts and Graphical Summaries. So the goal here is to understand characteristics of data and to show how data are used and misused in statistical studies. So we're going to move away from all of this stuff with counting, permutations, combinations, and probability. We'll come back to some of that stuff later, especially probability. We're skipping over chapter 4, and we're going to leave chapter 4 for later on in the course. And we're going to start jumping into the statistics and data side of our course. So a little bit of a refreshing change. So let's start off with a definition of statistics here. So what is statistics? So statistics is, let me just get my highlight settings here. Okay. So statistics is the gathering, organization, and analysis and presentation of data. You can apply statistical methods to do almost any kind of data analysis. Okay, this is going to become very important, especially as we do work on our culminating projects. And so this is kind of the foundation for all of that. So let's talk about types of data. So there are two main types of data, each of which has two subtypes. So the first type of data we're going to concern ourselves with here is numerical data. So numerical data, quantitative data. So this is data in the form of a number. So data in the form of a number. And you've been hearing me say numerical data so many times when I talked about doing research on data tables for your ISU. And this is what I mean. Just look for data, research variables, and things like that that can be that are numerical, that can be in the form of a number. Now, the subtypes. So you have discrete data, so data that are specific values. And you have some examples here for this. So what's an example of discrete data? The things that you can kind of like count, right? So we have grades. We have the number of correct answers on a test as a couple of examples. And then we also now have continuous data. Okay, so think of like data in a range. Think of, for those of you who took functions before, continuous functions and discrete functions. So discrete functions where we can discretely count numerical values. Continuous data takes on any value in a range. So I'm going to write here as my definition, data that takes on any value in a range. Okay, so what are some examples of continuous data? Weight, time, cost. These are some examples of what continuous data could look like. Okay. All right, so on the other side of numerical data, we also have categorical data. So data that's not necessarily, can be in the form of a number, but it could still be data that's counted, okay? But it's more like qualitative data. So data that are types that can be counted. So data that are types that can be counted. Okay, so one type of subset or some subtype of that is ordinal data. So this is data that can be ranked. Okay, so what kind of data can be ranked? Well, a rating scale. You rate things from 1 to 10. Or 4-star, 5-star hotels, rating out of stars. Even like on report card, when you see the learning skills, N, S, G, and E. Okay, or things like poor, good, excellent. So not necessarily numbers, but these can be ranked. Okay. Then you have nominal data. So nominal data is data that cannot be ranked. So data that cannot be ranked. Okay. So things like colors are examples of that. So color of eyes, perhaps. Maybe the make and model of your vehicle. Or your favorite something, favorite food, favorite book, favorite movie, dot, dot, dot. Okay. So this is data that cannot be ranked. And I'm just going to say here, these are like true type. All right. So these are the kinds of data we're going to be studying. Your thesis is going to be mostly focusing more on numerical data. But the focus of this section is just how do we take data and display it? How do we graph it? How do we show? How do we reach an audience using the data that we collect? And that's very important, because what good is data if you cannot use it to make a point, or make a presentation, or make an analysis? So in order to analyze data, it is useful to display data using tables and graphs. You can use a variety of graphical summaries to display data. Some are better for categorical data, some are better for discrete data, while others are better for continuous data. So let's look at one type of way we can display data. This one's called a frequency table. Okay, and what does this frequency table do? Well, it counts the occurrences of each criteria being measured. Okay, so your criteria is, well, what's your method of travel? Walk, bike, car, or bus? The number of occurrences is your tally. So you're counting, well, this person, there are 9 people who walked, 3 people who biked, 6 people who took a car, and so on and so on. And the frequency will just count up the number of tally points. And then here in the table, there's not necessarily you have to have this, but you can also have a percentage of each of the frequencies out of 100. So what is this useful for? Well, it's kind of useful for all data types, actually. So you can use this for both continuous, discrete, nominal, ordinal data. So it's can use for all data types. So you can use for all data types. Often it is used a lot for discrete data, because you're just counting some things. All right. Bar or column chart is another way we can display data, and this is a good way to display discrete data. So this is a good way to display discrete data. Okay, why? Because we're not talking about a range here, we're just talking about discrete numbers. So we're looking at pupil-teacher ratios here. So notice that the bars do not touch. That's very important. So bars do not touch. You might be wondering, well, I've seen graphs before where we had bars that look like this, but they do touch. Were they wrong? The answer is no, though that's a different kind of graph. Okay, it looks similar, but it's a different graph. A histogram has the bars touching. A bar graph has the bars separated. And histograms are normally used for data that has ranges in it. For bar graphs, however, we don't have ranges, so we can use it for discrete data, and we can also use it for things like categorical data. So it can also use for categorical data. Categorical data. So just imagine that instead of the numbers here on the bottom with the ratios, you can have, let's say, a person's favorite color, and you'd have black, blue, red, yellow, green, purple, white, etc., and you can discretely count those values. So it's also useful for categorical data that you have written in words. All right, so we have another type. So here's that one I was talking about, histogram. So this is where we use this type of display to show continuous data. So we're going to say here use with continuous data. Okay, and it displays data in intervals. Okay, and the connected bars, they're the kind of the way to show that continuity as you're going from one bar to the next. So the bars touch. I mean, that's from one interval to the next. So notice the bars touch here. Okay. Then we also have pie charts. Okay, so pie charts or circle graph, they're only used for categorical data. So only for categorical. Spelled that. So data. And it's a good representative part of a whole. So good representative or representation of a part of something to the whole thing. A part of a pie or slice of pie to the entire pie. So it's a very visual kind of graph. It's often used in many kind of presentations in the workplace. However, I will argue as a math teacher that pie charts should not be displayed in three dimensions. Okay, it should be displayed as a two-dimensional graph, and the reason why is because when you're creating this depth, what you're doing is creating a skew. You might be making these smaller slices of pie up in the front appear bigger uh, in proportion to what everything else is in the pie. Okay, so and sometimes this is done to emphasize a point. So it's something that easily it's overlooked and not really known by everybody. So, but it is a common tactic to show emphasis on a particular part of a pie chart. So it's a source of bias, which would be something we will talk about in soon. But keep in mind, 3D pie charts good if you're trying to be very sneaky or strategic. But otherwise, it's to be perfect, or to be a more analytical or precise. A 2D pie chart is much better than a 3D one. Here's another type of display. We have a frequency polygon. So it's kind of a, I'm going to write here some notes. This one here. Another way you can call this is it's a line graph, basically. And it connects midpoints on a bar graph or histogram with a line. So these midpoints right here, you see these midpoints? So the middle of the entire bar is that midpoint. Okay? And all those midpoints are connected to the line. And we also have something called relative frequency polygons. Relative. Which are the same graphs. They show the shows same graphs, but with percentages instead of the frequency tallies that you see on the left side of the axis. Now, next type of display data, we have cumulative frequency polygons. Okay, so this one shows a rate of change in frequency of values. From one to the next. Okay, so if you look at this closely, someone with a score of 34.5, the frequency of that was less than 4. But how many people had a score of 44.5? It's not actually 7, okay, or 8. It's actually the difference between this one and this one. So this point here includes everything, all the tallied frequencies that come from before it. So that's why the line is always going to be increasing. Okay, so it's a cumulative frequency. It's the one that you just keep adding and adding the previous frequencies to get a higher and higher and higher number. So the impact or the significant parts of this graph would be where are the parts of the graph that are experiencing a bigger rate of change. So somewhere around here is a part of the graph where you have a big jump, showing a big increase in frequency from 54.5 to 64.5. So that's a cumulative frequency polygon. You also have graphs that you might be familiar with, like scatter plots, since from grade 9. So this shows relationships between two variables. I'm going to be using this kind of graph for ISU most likely because you are very familiar with it. And it's also very useful because you can determine correlations in data and trends in data. So you can determine correlations and trends in data. So you're going to take a whole bunch of data points that you found from your tables when you did your research in your ISU, and you're going to plot them in a graph like this, and you want to try and find out, is there a trend? And maybe there is. Maybe there's a positive trend that's going like this. Maybe not. But that's the kind of analysis we're going to be doing. And then you have some other graphs which are I mentioned, but they're not so very often used. We have relative frequency polygons, pictographs, dot plots, and stem and leaf plots. We're going to be looking at some of these graphs as well in this chapter. So let's look at an example. Suppose you did a survey of students to determine movie genre preferences and collected this data shown below. Use an appropriate graph to display this set of data. So what kind of graph could we use? Well, I mean, it looks like we have categories. So this is categorical data, and we're doing a little frequency count here. So there's several possibilities. You could use a bar chart, or a pie chart. Okay, or I mean, you can use technology, an Excel sheet, and make a graph that way. I'm just going to draw a quick bar chart here. So I'm just going to draw an axis like this, a vertical axis and a horizontal axis. And here I'm going to label in my graphs. Make sure you label them, frequency. On the bottom, I'm going to talk about genre. And title your graph, we'll just title this movie preferences. Okay, and here we have action, comedy, romance, drama, and sci-fi. Okay, and let's make a little kind of scale here. Let's see, 3, 4, 5, 6, 7. That should be good enough. Let's label this 4, 8, and let's say 10, 12. So skip count by 4. That should help us. So I'm going to just draw some bars here. So action goes up to 8. So I'm going to draw a bar going up to 8. And let's just make sure that connects nicely with the graph. Okay. So there's our first bar for 8. You should really kind of shade in your bars, but I don't have a, don't have like a shading feature here. So I'm just going to kind of do this. Okay. And I'm going to draw my other bars for, I didn't shade. Okay, let me draw in the bars first, and then we'll just shade and everything afterwards. So comedy goes up to 11, so it's just short of 12. So what I'm going to do is just maybe copy. No, I can't copy. I'm just going to draw another bar going to 11, try to keep the widths the same. And I have romance that goes up to 6, so somewhere here like this. And drama goes up to 2, so here. And sci-fi just slightly above drama over here, and I'm just going to just shift this to the left a little bit. Oops. Yeah. Okay, try to keep the spacing even as well, just for presentation. And I'm now gonna just color in my graphs. So maybe I can just use the pen tool here, just a few lines like this when you're sketching a graph. It's good enough. Okay, and so there's my example of a bar graph. What about drawing a histogram? Well, a couple of notes for drawing a histogram. So when there's a large amount of data that spans a big range, it is often helpful to group the data in order to make tables and graphs easier to construct and to interpret. A lot of our work here when we do our ISUs just going to be on the computer. This will be kind of helpful for us, but you should know how do you group data for histogram. So number one, the number of intervals should usually be between 5 and 20 and should cover all the values in the data set. 7 to 9 intervals are usually best for presentation. You don't want to be overflowing with a bunch of intervals and getting a bunch of small tiny bars. Make all intervals equal in length, and this is very important. Okay, they have to be equal in length. Determine the bin width. Okay, we call them, the ranges called bins. You can imagine you throwing your numbers inside a bin. Each of them have a different range. Divide the range by the number of intervals you want. Always rounds to the next integer. So if your range is between 0 and 100 and you want to have 7 intervals, and take your 100 and divide it by 7, right? And that's the size of your interval. And then round your answer if it's 3.1. You want to deal with nice numbers. Using interval notation, choose intervals so that there are no gaps in between them, and so that none of the data lies on the interval boundary. In interval notation, use a square bracket means including that number, and regular parentheses means not including that number. For example, the interval 40 to 45 means we include any number between 40 and 45, but we exclude 45. Okay, so square bracket means we're including that number. The round bracket means we're not. So it only goes up to 44.999999, that kind of thing. All right. Example, calculate the bin width that would make 5 uniform intervals, then make a frequency table and draw a histogram. All right, so what kind of bin width would we have here? So, well, we have to know what our range is. So we go from the highest number here is 14. So I'm just going to highlight this. So we have a 14 here. And the lowest number is 6. Okay, we repeated 6 elsewhere. So the bin width, the size of my interval, is going to be 14 minus 6. Biggest minus smallest divided by, well, if I want 5 bins, I'm going to divide it by 5. So the size of my interval is going to be 2. So I'm just going to write a little note here. We're doing the highest what happened? Okay, so highest minus lowest value on the top, and we're dividing by the number of intervals that we want. Okay, so the size of my interval is 2. So you notice here in my table, I'm just going from 5 to 7, 7 to 9, 9 to 11. My size of each interval is 2. So then we can just now count how many numbers we have here. So we have 25 values here. So we have to get 25 tallies altogether. And if I count all the numbers between 5 and 7, I'm going to have 1, 2, 3, 4, 5. So I have a frequency of 5. Remember, I'm only counting the values 5 and 6. I'm not counting 7 itself because I'm excluding 7. 7 starts in the next interval, so I'm going to count the 7s here. So 1, 2, my cursor's gone, 3, 4, and then I have to also count the number 8, at which we have 1. So I have 5 tallies in total, so frequency of 5. So numbers from 9 and 10. So how many 9s and 10s do I have here? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Total of 9. And how many 11s and 12s do I have here? Well, I only have 1, 2, 3, 4. And how many 13s and 14s do I have here? Well, I only have 2. Okay, so there's my frequency table. Check to make sure they total up to 25, and they do. Okay, and then you can proceed to draw a frequency table and draw a histogram. Okay, so here I'm going to draw my histogram. I have an interval in the bottom, and I have frequency on the side. And let's say I'm counting by 2s again. So 4, 8, and 12. And my intervals go from 5 and 7. So remember the squiggly line, you may have drawn it before. If you're starting from 0, you go into your first interval and skip all the numbers in between, 5 to 7. And the next interval is 7 to 9. And then we have 9 to 11, 11 to 13, and then we have 13 to 15. 5 to 7, I have about 5 of them, so I'm going to go up to 5 here. I'm just going to freehand this. 7 to 9, we have again 5, so again another bar like this. 9 to 11, we have 9 of them, so just above the 8, like this. 11 to 13, we have 4, so it's back down here. A little bit lower than the other two. Like this. And 13 to 15, we have 2, so half as much, just like this. Okay, and so there's our histogram, shaded in. The widths of each bar should be equal as much as possible. It wouldn't be a problem if you're doing this on Excel software or spreadsheet software. That's okay. All right, so task. Read through example 1. Oh, by the way, I was just hurrying here. If you did this by hand, use a ruler. Okay. So here's your task. I want you to read through example 1 on page 197 and example 3 on page 200. Take some brief notes to help you understand how data can be used and misused in statistical studies, and that there is variability in data. Okay, and then I also want you to work on the practice problems from the booklet. All right, and that is the lesson for today.